All right, so today we're going to start right with your reciprocal functions and cofunctions, which is lesson 7. And again, I'm going to fly through a couple of these because a lot of this is going to be a nice review for you. You've already seen it in the past. And then we will kind of venture into some trig graphs. And then we will return next week and do some more trig graphs. So kind of to be continued here. All right, so with lesson 7, the reciprocal function. So the first bullet point says that cosecant is the reciprocal of sine. So guys, what's the ratio for cosecant then? Instead of opposite over hypotenuse, what would I do? Beautiful, hypotenuse over opposite. I'm going to keep it short and simple like I said. Next, secant. So secant's the reciprocal of cosine. So instead of adjacent over hypotenuse, you're going to do hypotenuse over adjacent. Beautiful. And then next, cotangent is reciprocal of tangent. So instead of O over A, I'm going to flip it and do A over O. Remember that these are still positive in the places where sine, cosine, and tangent are positive as well. So we're still going to do ASTC too. So down below, these are going to be exact values. But the only difference from yesterday to today is now you're going to do a little bit with the reciprocals instead. So rewrite as a function of a positive acute angle, so that means a reference angle, and then find the exact value. Cosecant of 5 pi over 6. What do you think I should do with that angle measure? Put it in degrees. She is absolutely correct. So the shortest way to do this, instead of writing the 180 over pi and canceling the pi, is to just simply replace the pi with a 180. Okay, so you can do it either way. This way is just a little bit quicker. And let me know what you guys get from this. What is 5 times 180 divided by 6? 150, thank you so much. So 150. So we always really want to work with these in degrees as opposed to radians because it's just a little bit more user friendly. So 150 degrees is going to rotate all the way into quadrant 2. And now I need to turn this into a function of a positive acute angle, which is a fancy way of saying 180 minus 150. So I'm looking at a angle measure of 30 degrees. We're going to go ASTC. What does this reciprocal trig function go with? Sine, good. So actually we're good to go because sine is positive in the second. So here's how you compute this value now. I'm going to have you do the sine of 30 and then just flip it. So who remembers the sine of 30 from yesterday? You did it a lot. It's a nice one. 1 over 2, good. So then what would be the cosecant of 30? 2 over 1, which is just 2. Good. And that's the answer. 2 over 1, which is just plain 2. Okay. I think it's personally helpful to write the other one first and then flip it, because then you have it right there next to you. All right, so number 2. Now I want to do secant. So I'm going to do 2 times 180 divided by 3. All right, what do we get from this? So 2 times 180 divided by 3. Thank you, 120. Awesome. And what function does secant go with? Cosine, good. So now 120 is also in quadrant 2. So I'm going to sketch it. And then I'm going to go 180 minus 120, which is equal to 60. And again, you guys should notice these are all nice angles that you know the measurement of. That's why they're exact value questions. And then I'm going to label ASTC. And what do we know about cosine in quadrant 2? It's negative this time. Yep. That's just a note for you. And now I'm going to find the cosine of 60, and I'm going to flip it. So I'm going to do the cosine of 60, which is, do you guys know this one? 1/2, good. But I'm going to go negative 1/2 because of that quadrant. and then I'm going to take it and flip it. So the secant of 60, my answer is -2. All right, so just like that. How's that so far? Pretty good? Basically, you just keep building on the, everything that we had been doing. So now I'll give you a cotangent function. So cotangent, I'm going to start with 7 times 180 divided by 4. I feel like this is 4th quadrant, is it? What did you guys get from that? 315, thank you. It is the 4th quadrant. And what does cotangent go with? Tangent, very good. So I'm going to place a triangle right in quadrant 4 this time. And go from here. All right, so next, I'm going to do my reference angle. So I've got 360 minus 315, which is equivalent to 45. Then I'm going to label ASTC. And what do we know about tangent in quadrant 4, guys? It's negative. Excellent. So I'm going to make a big negative sign next to this problem. It doesn't go with quadrant 2, but I'm just kind of running out of space, basically. So this answer, so negative tan of 45 degrees. It's also a kind of nice one. Tangent, yep, good, -1. And what happens if I flip -1? It's still -1, good. That's it. So that's how those work. How do we feel in that section, guys? Okay? All right, so the questions below, 4 and 5, those would be the same exact type of thing. So again, all you would do is just take them, plug them in, and multiply them out. So I'm going to skip over those because, again, you've kind of done those concepts already. And I'm going to hop right down to number 6. So number 6 asks you to calculate the value of cosecant of A. So these are all assumed to be right triangles. So what trig function does cosecant go with as a reciprocal? Sine, yep. So it pairs up with sine. So sine is equal to O over H. So instead, we're going to do that cosecant of A is equal to hypotenuse over opposite. Okay, so what am I going to sub in for a hypotenuse here? 25, very good. That's always your largest side. And opposite A is, that's it. What do you guys think? Pretty doable? Yes, that's it. That's all there is to the reciprocal functions. Again, you've seen them before. That's why I figure we could kind of fly through some of them. So we will do the top 2 on the next page. Just these top 2. Let me do that. All right, so 7 says you have a right triangle. C is your right angle, and the sine of A is radical 3 over 2. So I'm going to go opposite radical 3 and hypotenuse, which is 2. Who remembers the other side on this? 1, good. I don't know if we need it or not, but it's helpful to get it anyways, just in case. So now we're going to find cosecant of angle B. Let's hear. So cosecant of B is equivalent to the reciprocal of sine, so it's hypotenuse over opposite. So for hypotenuse, I'm going to plug in 2, and for opposite, I'm going to plug in 1. That's it. Done. So down to number 8. In right triangle ABC, C is your right angle, and I think we need to set this one up. Yep. So let's go C, and if you guys wouldn't mind, let's go A up here, and let's go B right here. All right, so AC is 15. BC is 8. How would you go about finding your third side if you needed it? Yep, Pythagorean theorem. Yep. So this works out to be 17. This is what we call Pythagorean triple, the commonly occurring right triangle. So cotangent of A. So actually we didn't even need it anyways. So cotangent is the reciprocal of tangent. So instead of tan being O over A, we are going to substitute in A over O. So I'm going to do cotangent of A, because I gave you a lot of space, we might as well use it, is equal to, so adjacent to A would be the 15, and opposite would be the 8. Okay, and that's it. You just leave it as a little ratio like that. How do you guys feel with those problems? Are those okay? Easy? Perfect. I kind of figured that, so you can skip the 2 on the bottom. And then on this last page of this packet, we're going to do 11, and then 16, 17. That is it. And then we get to do some pictures, which I personally really like the trig graphs, so hopefully you like them too. All right, I apologize for this graph. This is going to be a little bit difficult to physically fit. So if you want, you can just make a new graph. I think that's almost what I'm going to do here. Yeah. Theta is in standard position and its terminal side passes through -3, +2. So this tells you your quadrant placement. That's why it's important. So I'm going to go to the left 3, and I'm going to go up 2. And now you're going to draw your triangle. So you're going to hook right to the origin, like we always do, and then you're going to drop your altitude straight down. I think you can fit that a little bit better if it's kind of on the side there. Now I'm going to label. I went left, so this is the -2. I'm sorry, -3. And then I went up. And then go ahead and find the hypotenuse. So you're going to do 3 squared plus 2 squared equals c squared. And yes, I deliberately dropped the negative because you don't need it anyways because it gets squared. So this would be the square root of, yep, very good. And again, no decimals, exact value only. And we want to find cosecant of theta. So to find cosecant, it's right in this little crease here. And I'm going to do cosecant theta is the reciprocal of sine. So instead of O over H, it is H over O. So for the hypotenuse, I'm going to sub in the square root of 13. And for opposite side, I'm going to sub in the 2. Done. And if you think about it too, guys, the hypotenuse can never be negative because it results from Pythagorean theorem, and when you square side lengths, they always yield a positive result. Okay, so just that x value was negative there. And sine's positive in that quadrant too, so we're good. How's 11? Pretty good? Okay. Pictures are definitely helpful when it comes to questions like that. So the last part of this unit, and these you did last year, you did not skip these, is a trigonometric relationship known as cofunctions. Co sounds like a word that you learn in geometry. What word does it sound like? Kind of. What geometric term has co in it? Yeah, I mean, you are right. Not what I was thinking of, but you are right. Clo, another good one. Great one, but just not what I was looking for. I was looking for complementary. It's okay. Okay, you guys had good guesses. These functions, they pair up together, and these are always complementary. So what does complementary mean they add up to? 90. Oh boy, we're rusty on that, aren't we? Well, I mean, you guys didn't really have a full geometry course, you know? So cofunctions are complementary, okay? So again, you did, I promise you, every geo class did do this last year. It's a very simple concept. And cofunctions are different than reciprocal. So the cofunctions that pair up together. Sine goes with cosine. Tan goes with cotan. And secant goes with cosecant. So how do you solve these? You drop the equal sign, you take the expressions, and you set them equal to 90. So number 16, sine and cosine, are they cofunctions? They are. So because they are, what you do, so I'm going to say, just to give you something here. Again, this is really one of those concepts that gets tested more on your georegions that you were not responsible to take last year, obviously. So we'll just kind of hit on it quickly. So cofunctions are complementary, sine and cosine works. So I do 16 plus theta is equal to 90, and then I just solve. Answer would be 74. That's it. It's no harder than that. So how about just one more? You just want to check and make sure they're cofunctions. That's when you can do this. So 17, cosecant and secant, are they cofunctions? Yes, they are. They have the word co that separates them, basically. So I'm going to do cofunctions, and I'm going to put a check mark. All right, so we are going to do 37 plus theta equals 90, because you ignore the equal sign. What's this answer? 53 is correct. Perfect. Okay, so that's your last trigonometric relationship that, again, you have familiarity with from last year, but just to kind of touch on it again. So you have reciprocal functions, which obviously you know are different, and then you have what's called cofunctions. Does everyone feel comfortable solving those if they had to? Okay, that's it. That's all there is to them. So if you have no further questions on your first 7 lessons, we are going to do some trig graphs. Okay? So you're going to draw some pictures. I really like doing these again. And do we have musical people in here? Yes, I thought so. I know that they always say that there's a relationship between like your trig functions and music. So maybe you will like these. That's my hope. Okay. So yesterday what we did is we discussed conversions from radians. I've got extras, no worries. And we convert from radians to degrees, so that's what you're going to use here. I didn't know it was a long time ago. Probably like, oh my gosh, like a month ago or something. Looks like this on the front. Yep. If you need one, come on up. Oh, okay. It's a huge one like this. If you find a blank one of yours, you can just bring it back, okay? Right. I've got another. Yep. Just because I wanted you guys to make sure that you had these packets, because these have all the graphs in them. Welcome. Because these are tough to do without having the graph paper. Okay. All right, so this is, yes, as I said, your next packet that says lesson 8 right at the top of it. So when we graph trig functions, so specifically today, what we're going to do is a sine and a cosine function. Your graphs are typically labeled in radian measures, okay? It's just the preferred scale for a trig graph. Now, what you want to do is you want to get comfortable going between degrees and radians. So let's see which of these you actually already kind of know. So what's pi equivalent to, guys? Okay, I'm sorry. Let me reword that. From yesterday, what did we use for pi? 180. Okay, thank you. I apologize. I asked that wrong. So 180. So what's this one? Pi over 2. 90 degrees. Good. What would pi be? 180. What would 3 pi over 2 be? 270. What would 2 pi be? 360. Good. And now I'm just going to go the other way. So this would be 0 degrees. This would be negative 90 degrees. And then negative 180. And so negative 270. And negative 360. Again, I want you to see both right now until you kind of get comfortable going to just radians. So the first thing we're going to do is we're going to type in all of those values for cosine and fill in the table. So your calculator's in degrees. So what I would like you guys to type in is cos of negative 360 and tell me what you get. Cos of negative 360. Yep, 1. Next value, what is the cos of negative 270? 0. These are from your unit circle actually too. Cosine of negative 180 is? Yep, negative 1. Cosine of negative 90? 0. Cosine of 0? 1. Good, keep going. Cosine of 90? 0. Cosine of 180? Negative 1. Cosine of 270? 0. And cosine of 360? Good. You guys see the pattern? Yes. Trig functions are periodic in nature, so these are always going to repeat and have the same pattern. So, using one of your colors, if you brought one, if you didn't, that's okay. We're going to graph the cosine function first. So, the biggest value we have to hit here is 1 and negative 1, right? Yep, and that is what we refer to as the amplitude of the graph. So, let's do this. 0, and then how about this 1? And then negative 1. Okay, just to space it out and make it look nice. So you're going to go negative 2 pi and 1. And we are going to graph negative 3 pi over 2 and 0. And negative pi, we are at negative 1. And 0. And 1. Back the other side too. You're going to repeat the same exact pattern. And then you're going to impress me with your artistic ability here. And you're going to draw a cosine curve. And this is a standard cosine curve with just an amplitude of 1. Okay, just try not to make it pointy. The smooth curve. And this first one is cos of x. Okay. How do they look, guys? Pretty good. You're not drawing any hard ones yet, so they shouldn't be terrible. If you have a second color, go ahead and switch. If not, that's fine. And now you're going to do the same table for sine of x. So all you would do is type all these in the calculator. To speed it up, I'll just give them to you, I suppose. But they all come right from your calculator. You don't have to memorize any of these. So they go 0, 1, 0. And then I'm going to go negative 1, 0, 1. And again, it does just repeat a pattern. And then 0, and then negative 1 and 0. And I'm going to do this one in red. Okay? So I'm going to graph what we consider a basic sine curve. So I'm at 0, up at 1, and 0, and negative 1, and 0. This is personal preference. I like to draw my curve before I go to the other side, okay? It doesn't matter what you want to, like whatever you choose is fine. Okay, now I'm going to keep going and continue my pattern. So continue your pattern. You can draw as you go, whatever helps you make the best looking graph. And down at negative 1. And back up. And if you're looking at these and you've got a very visual eye to you, yes, you can apply transformations to a sine curve to obtain a cosine curve and vice versa. Okay, So they can absolutely be flapped on top of each other with just some transformations and some phase shifts. So this one is my graph of sine of x. And again, just to start throwing some terminology around at you, these are what we call trig graphs. They have amplitude of 1. So they go up to 1 and down to -1. So the height is just 1. And they're basic. So these have a period equal to 2 pi. And what that means is I start and I make one full cycle at 2 pi. Okay. So below, we are going to start with the domain and the range. So the domain, those are the x values. These graphs could go on forever. There is no restriction. There is no place they are undefined. So my domain is all real numbers, okay? Again, there's no issues. But my range, what are the only y values this is going to stay between? Yep, 1 and -1. Awesome. So my range, I'm going to be from -1 all the way to 1. Oh, interval notation too, I apologize. So interval notation just means you do the square bracket like this. Okay, sure you guys remember that. It says, after how much horizontal distance will both the sine and the cosine curve repeat its basic pattern? This is called the period of the trig function. You guys remember what I said? I'm sorry, I already gave that away. 2 pi, yep. So these are periodic in nature. They keep repeating. So 2 pi. So basically every 360 degrees, it repeats the same pattern. And that is formally what we call the period of a trig graph. So it's just a vocabulary term. Okay, how do you guys feel with those so far? Pretty easy? Okay, we're just gonna do a couple more pictures for today. So we're gonna just take the graphs and we're gonna just stretch them out basically. Which one do we start with first? We go back to cosine? Yes, we do. Okay, so we're gonna explore the effect of changing the amplitude. Okay, so go back to your original color if you're using colors. So the grid below shows you the graph of a cosine function. So this is the one that you just graphed a second ago. And this one is scaled and this just goes by 1. So this would be 1, 2, and 3. And this would be -1, -2, and -3. I like that. And don't worry about the calculator part. We'll deal with that a lot more next week when you return. I don't want to have you change your calculator to radians, bless you, and mess up everything we've been doing the first 7 lessons, okay? So we're going to do this by hand because it's actually super easy. So what changed in front, if you guys compare these, is instead of cos of x, what does it say instead? 3. So what do you think it goes up to instead of 1? 3. You got it. So take your first color, and I'm going to make this one red. And I'm going to take these y values and multiply them by 3. Some of them won't change. So what does this one go to instead of 1? Yep. This one, 0 times 3 stays the same. What does this one stretch down to? Good. And then the other one stays the same because 0 times 3. And then the last one, this is 1, so this would be up at 3. I like to start it. Okay. Now, aren't I just going to repeat the same thing on the other side? Yes. So this one is at 0. This is down at -3. And then 0 and 3. Okay. Nice, smooth curves. All right, and my label, this one is 3 cos x. I'm trying to keep it kind of simple for you because you're going to have 3 additional graphs on this one, okay? Switch colors if able. Obviously, when you return next week, you know what we're doing. So colors are, I think, helpful. So I'm going to do this next one in purple, we'll go. And I am going to instead multiply by 4. But what you'll see is there's a negative sign in the front. You learned about this before. What does a negative in the front mean that this graph does? Good. Better. Yes. So this is a reflection over the x-axis, and it goes up and down to 4. Good. Okay. If you can process all that at once, great. If you want to do it in 2 separate steps, I understand completely as well. But what I'm going to think about is this point would go up to 4, but now instead it goes down to -4. Okay? The points on the mirrors do not change. So that one stays the same. This black point right here from the original, because you always go back to the original, this goes up to 4 now. And then back to 0. And then I'm going down to -4. And again, if you can build half of this, that's going to help you out a lot. Okay, now I'm going to do the other side. So I'm at 0, up at 4, and then 0, and then -4. All right. So this one is -4 cos of x. So what we'll eventually discuss in further detail is that this graph got reflected over the x-axis and it has an amplitude of 4. You guys getting the hang of it? Okay. Next one. Let's do the 3/2 one. So 3/2 is going to go up to just 1.5. And you always go back to the original. So I'm going to use the this one right here. So I'm going to go up to 1.5 instead. Let's see if you guys can see orange. I'm going to go orange on this one. And again, this is just what we consider amplitude of 3/2. So I'm going to stretch this a little bit. That one stays the same. That one stretches a bit. That one does right on it. And right here. Again, hopefully you like them. They're kind of fun to do. You can make them really pretty. And back down. And my last point would be right here. And this one was 3/2 cosine of x. Okay. I suppose I'll let you skip that last one there. You get the hang of it, right? Okay. It gets tough when you have so many of these on one paper, as I'm sure you can see. So the only difference with the last one, we'll just verbally discuss it. It's a reflection over the x-axis with an amplitude of what, guys? 2. We're in Spanish now. That's fine. All right, so you're going to do the same type of transformations with a sine curve. And again, we just talked about this word amplitude, and amplitude is your height, and it is always a positive value. So it's the height, and again, it's always positive. That negative means the graph got reflected. It does not mean the amplitude is negative. All right, let's do a couple sine curves, and then I'm going to give you some time to get started on assignments. You don't have any of these to do yet. I just wanted to kind of start you guys. All right, this is back to a sine curve instead. So the first sine curve that we need to create is going to go up to what? 2. Exactly. I'm going to go 0. 1 gets stretched to 2. That one stays the same. Down to -2 and 0. As far as a transformation goes, in the past, this was referred to as a vertical stretch or a vertical scaling, your Algebra 1 teacher may have said. And then 0, and then down to -1, and back up to 0. Okay? Again, I like to color coordinate these, which kind of does take care of my labeling, but I'll put them there for you too. So this is 2 sine of x. Okay, so let's do, we will do, the 1/2's a little bit, you can fit that, I suppose. All right, so 4 sine of x comes next. So 4 sine of x would have an amplitude of what? 4, good. So you're gonna go all the way to the top. And that is how you go to label these axes when they're not labeled for you. So this one is amplitude equal to 4. Just in case you want that written, if that helps you. So 0, and then I'm gonna go up to 4, and then 0, down to -4, and 0, like this. All right, up to 4, and 0, and down to 4, and back is 0. Nice little change of pace for you to be able to draw. All right, so this one was 4 sine of x in red. Okay. We'll just do one more. We will do -3 sine of x. So there's 2 things you have to consider with this one. So what does the negative mean it's going to do? Flip. Yep, reflect. Excellent. So this is a reflection over the x-axis with an amplitude equal to 3. So amplitude is +3, and then this is also going to reflect over the x-axis. And again, do this off of the original. So go back to the first one that was drawn there for you. So reflect over the x-axis and then 3. So this point stays the same, and this one goes down to -3 instead. This one stays the same, and this goes up to 1, 2, 3. All right, so I have this so far. And then 0. And -3. Up to 0. And 3. And 0. All right, so this is -3 sine of x. Okay. What do you guys think? Do you like them? They're not bad, right? Okay. So we'll do a lot more with those next week, obviously, when you return. So you have 3 assignments for this week. You've got 2 Delta assignments and you've got a test to do. Take your time on those, please, okay? And there's one question I did post to like a written out hint for you on Google Classroom. So if you struggle with that, please see that post. I want to give you an opportunity to get started on that. Next week is the end of marking period 2. So do your best work, please, on those 3 assignments. Again, the test is a little bit long, so please don't wait until the last minute. But you're welcome to get your books out now and do your review assignment or the other one too. Be careful how you type radicals. And of course, if you have questions or need anything, just reach out.